Hello everyone, I hope all of you are doing good, and today I am here with a new video. Yes, so welcome you all to this session where we are going to start data handling class 7 maths. I am Roshni from LearnoHub, the free learning platform where you can learn maths, science and all the tips and tricks videos absolutely for free at learnohub.com. So what exactly are we going to do in data handling? What's data? Let's take an example. Let us suppose that there are 50 students in your class and it's results time. So everybody got their scores in all the 5 subjects. Okay. Now as a teacher, I have a lot of data to handle. For example, for each student, I have 5 scores in 5 different subjects. And similarly, I have the scores for all the 50 students. So just imagine the amount of data that I have. So these scores, these are my data. Right? So there is so much of data. So data handling actually means that how do we organize or handle this data better so that we can we can analyze this data and get some information out of it which could be useful for a lot of other purposes. So that's all about data handling. So in this particular video, we will talk about what is data, how do we organize data, and we will also introduce you to range of data and arithmetic mean. So that's the agenda for this lesson. However, we will complete this entire lesson of data handling in 3 videos. The playlist to all the 3 videos is given in the description below, so you can definitely check it out. So in order to get your concepts crystal clear, I would recommend you to watch all these 3 videos completely. So are you all ready to learn with me? Let's get started.
Data. What exactly is data? Let us look at some very common examples from our day-to-day life. Let's think of a situation when your class teacher is taking the attendance of your class. Now, why does the class teacher needs to take attendance? Just to make sure that how many students are present, how many students are not present, and some of the students might be trying to be more absent in the class. They are not present most of the time. So just to analyze all these things, is the entire purpose of having an attendance, right? Okay, now in a class, approximately how many students are there in your school? So in each class, you have some 40, 50, 60 or even more number of students. Now let's say that the attendance of class 7th for the month of September is somewhat like this: 15, 14, 17, 19, 10, 6, 17, 15. Now what is this? This represents the number of students present on each day of September. Now in the month of September, you have a total of 30 days. Let's assume that you have 20 to 25 working days, and the attendance of those 20 to 25 working days is given as you can see on the screen. Now looking at this data, if the teacher is being asked that can you tell me on which day in September the attendance was maximum, that means on which particular day of September maximum number of students were present in the class. Do you think looking at this data the teacher can tell that very quickly? Not really, because when you look at this data, the data is like all similar numbers. They have been written with commas. So there is a lot of chance that even though you very minutely look at the data, you might miss out a number or 2. So it is quite difficult to analyze the data looking at this huge set of data. So if the teacher is being asked that how would you know which student is bunking the class most often? So that is again a difficult question for the teacher, because this data just tells him that how many students were present on a particular day of September. So these kind of questions like who all are present, which specific students are absent or which specific students are present, that is very difficult to analyze from this given data. Who is the best attendee? Which is that student who attends regularly? That means he is never absent. Every time he is present in the class. So that is also a difficult question to be answered looking at this data. So these are some of the questions which cannot be easily answered looking at this data. Let's look at another example. Let's say that there is a cricket match going on, and the score of the cricket match, that is the runs scored in the cricket match by all the 11 players, are given as follows: 50, 100, 80, 10, 15, 6, 15, and so on. Now again, when you look at the data, even though this is a smaller data when compared to the previous example, so here you just have 11 numbers. But if I ask you that which particular player scored the maximum runs, in that case you actually need to compare all the 11 numbers and need to find out which is the biggest number, and only then you can say, okay, this player did this. But even in that case, let's say that even if we see that 120 is the biggest number, but it is very difficult to say that who scored 120 because no such name is given, right? Or who scored less. So these kind of questions are difficult to be answered looking at this kind of data. Now, what are you actually understanding about data with these examples? What exactly is data? Data is nothing but these numbers which are written on the screen. So in the first example, data was nothing but the attendance of the class on different days. In this example, data is nothing but the runs scored by the 11 players. So data is nothing but numbers. Well, it is not really like that, but let me give you some more examples. Let us now think of a shopkeeper. So this guy in blue shirt is the shopkeeper, and the kind of sale that he does from his shop, there is a data that how much was his sale for different items in a particular year, and it was something like this. So 46,000, 51,000, 1,30,000, and so on. So this was his sale. So this is the amount of sale that he did in that particular year for different items. Now, what are those items? Because in his shop, he might, if it is a stationery shop, he might have various items, like it could be books, pencils, pens, sketch pens, scissors, glue. So it could be anything, right, in a stationery shop. But which is the sale for which particular item, that is again not mentioned here. So again, you see, looking at this data, it is very difficult for the shopkeeper to analyze anything, because why do we even need this kind of data? Why are we even talking about these kind of numbers? That's because with the help of this data, the shopkeeper might be able to manage the inventory of his shop better for the next year. Let's say that in this particular year, he bought, say, 50,000 pencils, but none of them were sold. So he gets an idea that pencil is an item which is slow moving. So people really do not buy a lot of pencils from his shop. So for the next year, he might plan in such a way that he doesn't keep a lot of pencils in his shop. So this is how analysis of data helps the shopkeeper. And that is why he wants to analyze the data. But looking at the data of this kind, it is very difficult to do a proper analysis. So some of the questions like this might be helpful for the shopkeeper to plan for his next year, like which items give better sales so that he can buy them more, which month gives better sale so that he can have a good stock in his shop during that month, which items are slow moving so that he can avoid buying them. So these are some of the things that's going to be helpful. But unfortunately, with this kind of a data, it is very difficult to find answers to these questions. So at the end of these three examples, what do we understand? What is data? Or why do we even need to analyze this data? Now, first of all, let us see what is data. Data is nothing but collection of facts or statistics. Now, here in all the three examples, data was represented by numbers. Now, these facts or these statistics could be anything. It could be the scores of students in a class. It could also be the number of students present in a class. It could be the amount of money in rupees earned by a shopkeeper during a year. It could be anything. It could be the amount of fruits that you have bought throughout a year. So it could be anything, any data, any information or any facts that you have. Now, why are these facts? Because when you see here, let's say scores of students in a class. So this is like some true facts, some true information, right? So when you have too many such facts, they are together termed as data. Now, looking at the last three examples, what do you think? Why do we even need to analyze these data? So that we can take better steps in future. For example, if you think about the attendance of class 7th, now if the teacher is able to analyze the attendance data well, then he would be able to handle students, or he would be able to ask students to be more punctual, those students who are not attending classes regularly. Right. Similarly, if a proper analysis of the scores by different players in the cricket team is done, then the captain can actually, make better decisions so that the team as a whole can work better in future. Similarly, the shopkeeper, after analyzing the data, can manage his inventory better in the next year. So this is how the analysis of data helps us. So now we talk about organizing data, because we saw that with these kind of haphazard data, we really go nowhere. We actually are unable to analyze the data properly. Therefore, here we will see how better can we organize data. Now let's say the data that is given to you is the score of students in a particular class. So here you see 75, 45, 70, 70, 42, 55, 61, 71, 82. So these are the marks obtained by various students in a class. Now, let's say that the teacher has been asked to organize this data in a better way so that he can, give answers to such questions like who scored maximum, who scored minimum, and what was like the overall performance of the class. So that he is able to answer all these questions in an easier way. Because now if you look at this given data on the screen, it is very difficult for the teacher to handle this data. So let us look at some better ways of organizing the same set of data. So one way could be putting it into a tabular form. So you are putting it into a table. So where you have a column which has the names of the students, and you have another column where you have their respective scores. Now, do you think this is a better way than what we were seeing before? Yes, because in this case, you can very specifically see which student scored how much. So that's one advantage. The second advantage is that in this table, the way you see the data, so the data, like earlier, the data, all the numbers were written, I mean, there was just a comma separating the numbers. So it is very difficult to read out so many data. But in this case, you have one below another. So it is like more, it can be read more distinctly. So that way is also, it is more convenient, right? So this is definitely a better way of organizing the data. Now, a yet better way of organizing the data. Now see here what we have done, we have just mentioned that how many students have scored less than 50. Now in this case, if somebody asks you how many students scored less than 50, you actually need to find and count. Instead of that, if you already prepare a table where you say number of students who scored less than 50, who scored more than 70, who scored between 50 and 70. And if you prepare a table like this, then it becomes very easier to represent this data before someone. So you see, these are better ways of organizing the same set of data. So here in this lesson, we are going to focus on how do we handle data in a better way? How do we organize them better? How do we represent them better? How do we extract information from a set of data? So these are some of the targets that we have from data handling. So these are some of the better ways that we can organize a given set of data. Now let us think of this scenario. Let's say that the principal of your school asked your class teacher that how was the score of your class this time? Now, what do you think? What is the teacher going to do? Do you think that the teacher is going to read out the entire set of data, something like this, that, okay, sir, so the performance of my class was somewhat like this. They scored 75, 45, 70, 70, 42, 55. Do you think he's going to do that? Or do you think that that is a wise way of telling the principal how was the performance of the class? No, right? Okay, so then what should he do? Do you think that he should show this table to the principal, this entire table? Now here in this table, you just see some 9 or 10 students, but there might be some 60 students in the class. So do you think that he should hand over a big list of 60 students with their marks and show it to the principal? That is also not a very wise way of conveying the information, because it is not very convenient for the principal to read out the entire list and then decide, okay, how was the performance of the class? So what should the teacher do? Is there any other smarter way of telling the principal how was the score of the class? Yes, of course, there is. So what he does is, he tells the average score of the class. Now, instead of telling the individual score of each student, the teacher informs the principal that the average score of the class is somewhere around, say, 70. That means that there might be some students who scored more than 90. There might be certain students who scored less than 50. But when you average out them, that means, what do we mean by that? We mean that if we assume that all the students of the class obtained same marks, they all obtained equal marks, in that case we would say that each of them obtained 70. That is when we say that the average score of the class was 70. And exactly this is what the teacher does. He says that the average score of the class is 70. So this basically means that some students would have scored less than 70, some students would have scored more than 70, but if we assume everyone scored the same, then each scored 70. But actually not everybody scored same. There are students who scored 90, there are students who scored 50. But when you distribute marks evenly between all the students, then you can say that average score of the class is 70. Now, when the average score of the class is 70, the principal gets an idea about the overall performance of the class. So even though he doesn't get to know who scored 50 and who scored 90, but at least he gets to know that, okay, overall this class is performing average. That means there are certain students in the class who are not scoring that well, but at the same time there are certain students in the class who are doing very well. Now, instead of 70, had the average score of the class been 30, that would have very clearly conveyed a message to the principal that most of the students in the class are performing bad, right? So that way, the average score of the class helps to give a broader view of the score of so many students in the class. So this is where we introduce the concept of average. So when you have a huge set of data, sometimes in order to interpret or in order to get some information out of that data, instead of representing or instead of indicating all the data, what we do is we just take out the average. So this is the best way for the teacher to convey to the principal about the overall performance of a class. So here we talk about arithmetic mean. So arithmetic mean is nothing but a mathematical term given for average. So it is the most common representative value of a group of data. So representative value, that means a value that is very convenient and easy to represent, and at the same time that value conveys a meaningful information about a group of data. For example, when you look at the score of the students, so when you say that the average score is 70 actually gives you a lot of information about the scores of the students of that class. At the same time, 70 is just one single number which represents that entire group of data. So it is easy to represent as well. So it is a most common representative value of a group of data. It is also called as mean. Arithmetic mean or mean, they actually are the same thing. So let us take an example. So let's say that these two sisters, they have different heights. So one of them is, the younger sister is 128 centimeters and the elder sister is 150 centimeters. So they have different heights. One is taller and the other one is shorter. Now, if I ask you what would be the average height? Now, whenever I say average height or whenever we say what would be the mean of their heights, that actually means that we are trying to say that if we assume that both of them are of equal heights, in that case, what would be each of their heights? So how do we find out their average height? sum of their heights, that is 128 plus 150 divided by 2. So that means their total is being divided into two equal parts. That is what we assume when we talk about average. Average means if we assume that everybody got equal share, then what would be each person's share? For example, when I was talking about score, I said that if we assume that all the students in the class scored equal marks, in that case, the score obtained by each of them is called the average score of the class. Similarly, here if we assume that both the sisters have equal height, in that case, what will happen? The sum of their heights needs to be equally divided into two parts. So 128 plus 150, that is 278 divided by 2, which is equal to 139 centimeter. So this 139 centimeter is going to be the average height. So now when you look at 139, you see that 139 is greater than 128, and at the same time 139 is less than 150. So basically the average value is always a value which lies between the minimum value and the maximum value. So it lies somewhere in between, somewhere in midway between 128 and 150. So here we have considered just two numbers, that is here we just considered two girls. Now instead of two girls, let's say there are 60 students in a class and all of their heights are given, and if you are asked what is the average height of the class, what would you do? You would find the sum of the heights of all students in the class divided by the number of students in the class, and that is how you can find out the arithmetic mean. And there also you will find that the value of mean lies somewhere in between the minimum value and the maximum value in the set of data. So again we will now look at finding arithmetic mean. So we will take the same example of student scores. So these are the scores of the different students in the class. Now we already saw that arithmetic mean is equal to sum of the values of items divided by the number of items. So here sum of values would be something like this: 75 plus 45 plus 70 plus 70 plus 42 plus 55 plus 61 plus 71 plus 80. So this is the sum of the values divided by the number of items. So here items would refer to the number of students. So how many students do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this divided by 9. So we see the sum is 569 divided by 9, which comes out to be 63.2. So this is the average score of the class. That means if we assume that all the 9 students in the class got equal marks, then each of them would have got 63.2. Now when you look at this value 63.2, it lies somewhere in between the minimum value. Which is the minimum value here? 42. So 42 is the minimum value, and which is the maximum value? 80 is the maximum value. So when you look at this value, it lies somewhere in between 42 and 80. So it is greater than 42, but it is less than 80. So with this we can say that mean gives a measure of the central tendency of a group of data. So whenever we have a group of data, maybe we have a score of some 100 students in a class. So the value of mean will give us the central tendency of the group of data. That means like in this case, when you look at the average score or when you look at the arithmetic mean, it is 63.2. It lies somewhere in between the data. That is, the minimum value starts from 42 and the maximum value goes up to 80. So 63.2 lies somewhere at the central region of 42 and 80, because if you start arranging the score in increasing order like this, 42, 45, then 55, then 61, then 70, then 70, then 71, and so on. So you would see that 63.2 lies somewhere in between. So it lies somewhere in the central region. Therefore, the value of arithmetic mean gives a measure of central tendency of a group of data. So now we will talk about another important aspect that is called range of data. Now, instead of the asking the overall performance of a class, if the principal asks the class teacher, what is the range of students score in your class? Now, what is the meaning of range of score? Now, the term range always means the spread of data. That means, let's say that this is the score of different students in the class. Now, when we talk about range, what we want to say is, that means the marks obtained by different students, they are spread in what range? They are lying between what number till what number. So that is called the range. So range is nothing but the spread of data. So it indicates the spread of a group of data. So when you look at this example, you see that the minimum value here is 42 and the maximum value is 80. So you can say that the range of data lies somewhere between 42 to 80. So this defines the range of data. That means all the values or all the scores of students, they lie somewhere within this range of 42 to 50. So if I ask you to calculate the range, so the range will be equal to 80 minus 42. That means the difference between the highest value and the lowest value. And this comes out to be 38. That means the spread of the data is over 38 values. So all the data or whatever score we have, that score has to lie within these 38 values. So the scores are spread among 38 values from 42 to 80. So this 38 is called the range of the score of students.
Let us now quickly look at some of the questions based on whatever we have learned so far. Question number 1, organize the following marks in a class assessment in a tabular form. Okay, so this entire numbers which you see on the screen, like 4, 2, 6, 5, 7, 1, 5, 9, 3, 6 and so on, they represent the marks scored by students in a class assessment. So first we have to represent it in a tabular form. Tabular form means in the form of a table. Now, whenever we have to represent a group of data in the form of a table, what do? So the first thing that we do is we arrange the data in a particular order. So we prefer arranging it in increasing order or ascending order. So let us first prepare the list or the table. So let us say this is marks. So here you will have marks. So in marks, what are the different marks? Which is the minimum marks that you see here? So the minimum marks is 1. So basically when you arrange it in this form, you see that certain marks get repeated. For example, when you look at 2, so 2 has been repeated twice. So instead of writing 2 twice, what we can do is we can just write it once, and then here we can have a separate column for frequency. That is the number of times 2 gets repeated. So 2 gets repeated how many times? 2 times. And here we put the tally symbol. So 2 is repeated 2 times. 1 is repeated 1 times. What about 3? So how many times do you have 3? 3 is repeated 1 times. 4 is repeated 3 times. 5 is repeated 1, 2, 3, 4 and 5 times. 6 is repeated again 4 times. 7 is repeated 2 times. 8 is repeated once and 9 again is repeated once. So basically, now why do we have these kind of tally marks? You know, it helps us because, like for example, for 4, you are counting how many times 4 exist in this huge set of data. So every time you see a 4, you just put a straight line like this. So whatever number of straight lines you get, the frequency is that much. So here the frequency is 1, here frequency is 2, here it is 1, here it is 5, here it is 4, 2, 1, 1. So this is the frequency for different marks. So this is a very organized tabular representation of the data, and often this is known as frequency distribution table. You will learn about this table in more detail in your next class, that is in class 8. But for now, I just introduced it so that you can understand that how beautifully we can organize a group of data. Now, another simple way of organizing this data in a tabular form is you do not include this concept of frequency.
all you do is you just organize the data in ascending order, something like this. So you just have a column called marks, and under marks you just write everything the way it is, just that you arrange them in ascending order. We didn't have enough space, so it went like this. So in this way you can arrange all the marks in increasing order. This is also a simple way of organizing this data in tabular form, but definitely this is a more improvised way of arranging the data. Fine, so we have arranged it in a tabular form. Now let us try to answer the questions. Which number is the highest? Now looking at both the tables, you can very easily say which is the highest. The number which is at the end, that is 9. So the highest number is 9. And which number is the lowest? Again, the first number, that is 1. So 1 is the lowest. What is the range of data? Now I have already defined range. How do we find range? Range is always equal to the highest number and the lowest number's difference. So highest minus lowest. So highest is 9, lowest is 1. So range will be 8. Fourth one, find the arithmetic mean. So how do we calculate mean? You remember, mean is nothing but sum of all the observations divided by the number of observations. So how many observations do you have? Now in this case, in order to find mean, you would actually need this table, because if you use this table, it might confuse you, because here you have not repeated each mark as many number of times as they are occurring. So if you just count 1, 2, 3, 4, 5, 6, 7, 8, 9 and you say there are 9 items, so there are not 9 items. There are more than 9 items, because certain items are getting repeated. Correct? So it is not basically how marks of how many students are there. So that how many gives you the number of items. So you count it from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So there are a total of 20 students, because there are 20 marks. So therefore the number of items will be 20, and what would be the numerator? Numerator would be the sum of the observations, that is 1 plus 2 plus 2 plus 3 plus 4 plus 4 plus 4 plus 4 plus 5 plus and so on till 9. Now when you find this sum, it comes out to be 100. So 100 divided by 20 is equal to 5. So the arithmetic mean of the marks is 5. So what does that mean? That means that if we assume that all the students in the class got equal marks, then each student got 5 marks. So that's the meaning. So this is how we can organize data and we can calculate arithmetic mean. So let us look at the next question. Question number 2. Find the mean of the first 5 whole numbers. Now first of all, what are whole numbers? Numbers starting from 0 till infinity. So what are the first 5 whole numbers? Let us first write them down. So first 5 whole numbers would be 0, 1, 2, 3 and 4. These are the first 5 whole numbers. Now when we have to calculate their mean, so mean would be sum of the numbers. So mean would be sum of the numbers divided by number of numbers. That means how many numbers do you have? So that's number of these numbers. So sum of the numbers would be 0 plus 1 plus 2 plus 3 plus 4 divided by how many numbers you have? 1, 2, 3, 4, 5. So divided by 5. So this is equal to 10 divided by 5, which is equal to 2. So the mean of the first 5 whole numbers would be 2. Question number 3. Following table shows the points of each player scored in 4 games. Now there are a couple of questions that you need to answer. First, find the mean to determine A's average number of points scored per game. Now A has played in 4 games, game 1, 2, 3, 4. So we have to find average of A's score. That means we have to find arithmetic mean of the scores in games 1, 2, 3, 4. So how do we find the average? So the average would be nothing but the mean. So it would be the sum of the scores divided by the number of games in which the player scored. So this mean would be equal to 14 plus 16 plus 10 plus 10 divided by the number of items. How many items do you have? 1, 2, 3, 4. So this divided by 4. So the sum comes out to be 50 divided by 4, which is equal to 12.5. So 12.5 is the average score of A in each game. Now to find the mean number of points per game for C, would you divide the total points by 3 or by 4? For C. Okay. So in case of C, how is the thing different? Now in case of C, if you look at it, he did not play in game 3. So he actually did not play in all the 4 games. So how many games did he play? He played only in 3 games. So therefore, when we calculate the mean, what we will do? We will find out the sum of his scores, which is 8 plus 11 plus 13. And we will divide it by the number of games he played. How many games did he play? 1, 2 and 3, because he did not play this game. So we will divide it by 3. So therefore the sum would be 32 divided by 3, which is equal to 10.6. Therefore the average score of C would be 10.6. So please understand this. Now had he played game 3 but scored 0, in that case we would have divided it by 4 because he had played that game, but he performed bad. But in this case he did not play that game at all. So therefore this game will not be counted. Let's look at the third question. B played in all the 4 games. How would you find the mean? So let us try to find out the mean of B. So mean of B would be sum of his scores, which is 0 plus 8 plus 6 plus 4. And how many games did he play? He played 4 games. So here in this case you can see the difference. In case of D, he played game 1 but scored 0. So we counted this as a number of game. But in case of C, he did not play game 3, so that was not counted. So now when you find this sum, it comes out to be 18 divided by 4, which is equal to 4.5. So the average score of B is 4.5. So now the last question is, who is the best performer? Now when you look at the average score, so if you compare, you would see that the average score of A is greater than C, which in turn is greater than B. Even if you look at the total score, what do you see? So even if you try to compare the total score, how will you find the total score? Just by finding the sum of the scores in all the 4 games. So in that also you would see that A is greater than C, which in turn is greater than B. So definitely A is the best performer. The rainfall in a city on 7 days of a certain week was recorded as follows. Find the range of the rainfall in the above data. Now, even before we find anything from this data, let us first try to arrange this data in tabular form. Now, whenever we arrange this data in tabular form, what do? We first of all create 2 columns, one for day and the other for rainfall. And the most important criteria to arrange or to organize the data is that we arrange it in a specific order. So, we will arrange it in ascending order. So, let us start from the smallest values. So, which are the smallest values here? So 0, 0. So first let us write the 0, 0, and then what do we have? We have 1, then we have 2.1, then we have 5.5, then we have 12.2, and we have 20.5, right? So this 0, 0s, these are for Monday and Thursday. 1 is for Sunday. 2.1 is for Wednesday, 5.5 is for Saturday, 12.2 for Tuesday, and 20.5 for Friday. So this is how I have organized the data in ascending order. Now we have to find the range of rainfall. Now how do we find range? We know that range is nothing but the difference between the highest value or the maximum value and the minimum value. Now looking at this organized data, can you tell which day receives the highest rainfall? Of course, it is the Friday. And how much is the highest rainfall? It is 20.5. What about the lowest rainfall? So lowest rainfall is received by both Monday and Thursday and the value is 0.0. So therefore the range of rainfall is 20.5 millimeters. So this would be the range of rainfall in the above data. Now find the mean rainfall for the week. Now when you have to find the mean rainfall, what do? So in order to find the mean, we find out the sum of the data divided by the number of days for which the data is given. So let us find the sum. So sum would be 0 plus 12.2 plus 2.1 plus 0 plus 20.5 plus 5.5 plus 1 divided by, for how many days the data is given? 1, 2, 3, 4, 5, 6, 7. So this divided by 7. So the sum comes out to be 41.3 divided by 7, which is equal to 5.9 mm. So this would be the average rainfall for the week. Third question, on how many days was the rainfall less than the mean rainfall? So you have to find out those days when the rainfall was less than the mean rainfall. So basically you need to find out all those days where the rainfall was less than 5.9. So Monday is less than 5.9, Tuesday is not, Wednesday is again less than 5.9, Thursday is again less than 5.9, Friday is not, Saturday is 5.5, which is less than 5.9, Sunday again is less than 5.9. So therefore on 5 days of the week rainfall was less than 5.9 millimeters. And what were those days? Monday, Wednesday, Thursday, Saturday and Sunday. Question number 5. The heights of 10 girls were measured in centimeters and the results are as follows. So these are the heights of 10 girls. So there are a couple of questions being asked in this regard. So even before we answer these questions again, what we will do, the first thing that we do is we arrange the data in ascending order in a tabular form. So we create a table with just one column, that is height, and then we put this data arranged in ascending order from smaller to bigger. So 128, 132, 135, 139, 141, 143, 146, 149, 150 and 151. So this is how we have arranged the height in increasing order. So the first question is, what is the height of the tallest girl? So tallest girl, that is the height at the end, because this is the biggest number. So 151 centimeter would be the height of the tallest girl. What about the height of the shortest girl? So definitely the shortest girl would be 128 centimeters. What is the range of the data? So range is equal to tallest minus shortest, that is 151 minus 128, which is equal to 23. So 23 centimeters is the range. What is the mean height of girls? How do you calculate mean height? So mean height is going to be the sum of the heights, that is 128 plus 132 plus 135 plus 139 plus so on till 151. So you add all these values and divide by how many? Divide by 10, because these are the height of 10 girls. So you have 10 such values. So this comes out to be 1414 divided by 10, which is equal to 141.4 centimeters. So this is the mean height of the girls. How many girls have heights more than the mean height? So how many heights are greater than 141.4? So all the heights starting from 143. So all these heights That is 1, 2, 3, 4, 5. So there are 5 girls who have a height greater than the mean height. So these are the girls 1, 2, 3, 4, 5. So their heights are greater than 141.4 centimeters. So you see, do you see the advantage of arranging the data in increasing order? It becomes easier for you to calculate the range. It becomes easier for you to decide which all data are greater than a particular value, which all of them are greater than the mean height, which all are less than the mean height. So that means arranging the data in tabular form helps.
I hope this video was useful, but as I always say, that maths is a subject which needs a lot of practice. It's not enough to just watch the video. You need to first watch the video and then need to solve some problems on your own. And if you're able to do that, you are done. So if you really like the video, do not forget to share it with your friends so that more children can enjoy learning with this video. If you have a feedback for us, do let us know in the comment section. We will be more than happy to hear from you. So I will meet you all very soon with a new video, with a new topic. Till then, stay home, stay safe, take care. Bye-bye.